Hi peers, this will be my final report for project 2 of our creative engineering course. I've had a few setbacks in this project. My first one was I was going to get a large print of Van Gogh's Starry Night painting and do some backlights of the stars and the moon from behind an acrylic print of the painting. And I'd done some research and found that that looks pretty good. I mean, you can backlight the stars and the moon and probably bring some interesting thing, have some Arduino control fading in and out of the stars. That idea failed because I wasn't able to get the print fast enough. It was going to take something like 7 to 10 days just to get a print. So I had to go to my backup plan, which was I thought I would, just so I could learn more about the Arduino, I wanted to try to automate my project 1, which was these kitchen sheet dispensers, where you could cut sheets of paper. So I thought, well, why don't I try to automate that? Because we've got motors in the kit, we've got controllers, sensors, and so that's what I decided to do. I decided to try to automate this kitchen sheet process. So I put together my requirements. Things like the cutting operation had to be less than 2 seconds, which ended up being kind of a pivotal requirement. And I went through my design. The idea was to take one of those slider cutters like I used in the first phase, gear it up so that it moved fast, because I did some initial testing with the stepper motor and found out that it takes about 4 seconds to do one revolution, and that's about the fastest I could get out of the stepper motor. So went together, put my requirements together, and again decided to use the Arduino controller and the stepper motor for the drive, which ended up being a fatal decision. So one of the things I did early on is I went through the calculations to determine what kind of gearing I was going to need to be able to make my 2-second requirement. I ended up finding a 72 tooth gear and a 9 tooth pinion gear, which is going to give me an 8-to-1 ratio, which is going to result in something like about 1.6 seconds for the cutting operation to happen. Now, I tested the stepper motor using the joystick, but that was after my initial idea was to use the IR receiver, and I couldn't get that to work. So I got responses from the IR transmitter, but they were always zeros in the code. So if anybody knows what I might have been doing wrong there, just please give me a comment on if you've run into the same problem and know how to solve that. But then I went through and put together some of the risks. Is the fishing line approach for the belt going to work? Is there going to be enough traction, enough friction for the pulling mechanism? Will the stepper motor provide enough power to cut? So let's move over and take a look at the final result now. So here we are at my prototype build. Over here on the side, underneath here is the stepper motor. I've got one of these little attachments I found on the internet to give me the ability to tie to give me a flange to glue this 72 tooth gear to. And then underneath here, to drive this pulley, I have a little pinion gear. Started out with this 8 tooth, but turned out the mechanism wouldn't even work with the 8-to-1 ratio that I needed. So I ended up getting a 20 tooth pinion, which means I can now move the mechanism using the joystick. And the idea was to finally make this so that you could press on one side or the other to activate the cutter. But now that I'm here, I found out these stepper motors just don't have any power. If you try to, say, cut this piece of wax paper, nothing. It just, the motor just barely has enough power to even move the cutter at all. So, lesson learned. So thanks everybody. I appreciate any feedback on how to make this idea better, but I think I'm going to move on to project 3 and see how that goes.